scaling reinforcement learning on Modal. So our agenda is that first we'll talk a little bit more about some basic building blocks that you can use on Modal to run training jobs or any sort of jobs. Then we will talk about what an RL infrastructure stack will look like. Then we'll walk over some code examples of integrating RL infrastructure and scaffolding that on top of us. And then lastly, we'll go over some common design patterns. Oh, someone's saying it's still echoing. Okay. Okay, all right. So, just a quick poll. Who has used Modal before? And who has maybe not used Modal? Nice. Okay. Great. Okay, so most people have some familiarity with using Modal for training or just using Modal in general. So I'll breeze through this particular section. But essentially, on Modal, you have functions as our primary primitive, which is just code that runs on the cloud. So on the right, we have an example function that just prints hello world. You can use functions essentially to spawn training runs in parallel. You can also use these functions to run batch jobs to generate and process datasets, and you can also use these functions to run evals. We also have volumes. So who has used volumes here before on us? Volumes are essentially our high-performance distributed file system, so you can use them to read and write checkpoints and also do data loading. So here in this example, we use a volume inside a function, and here the volume is mounted to data, so we can just open a data file and it will just automatically, even when the function finishes, still be in this volume. And then we also have sandboxes. So sandboxes are just container primitive that we have that can execute arbitrary code and do anything, but you can just think of sandboxes as like containers you can do. So in this code example, we created a sandbox. We executed Python and print hello, and you can read the output. There are a lot of things you can do with sandboxes, and for that, you can also refer to our sandbox webinar that we did. But the primary use case for sandboxes for training is making RL environments. Okay, so, and then lastly, I want to talk a little bit about Flash, which is a way we can do, inference well. And here we have a more complicated example of Flash. Flash serves well with training, as we'll see later, because as you are doing training runs, you will also need to do inference. Okay, so these are some things we can actually run on Modal. So now I want to talk about any questions here, by the way, before I go on. Okay. So now I want to talk about some design goals that we have for RL infrastructure. So when we want to do RL, what are some things that we might care about our infrastructure having? Like what do we think are some important design goals or qualities we expect from our infrastructure? Yeah, so Rick said consistency in configurable environments. Yeah, that makes a lot of sense. Yeah, so consistency is important because we want the infrastructure to be stable, and configurable environments is also good because we want to be able to do a lot of testing across various different configurations. Josh is saying checkpoints, which is good because if you don't checkpoint your training, then you lose progress halfway through if things go badly. Yeah, fast inference also makes sense. That also allows you to have higher throughput. Um, ability to parallelize workloads at branch points. Yeah, this one's interesting. I think what you're describing is being able to fan out your training runs. Reproducibility also makes sense. An easy way to integrate reward function is also interesting, which we'll talk a little bit later. Um, someone said checkpoints and then they learned the hard way. Yeah, yeah, for sure. If you don't checkpoint, often, then, you know, bad things will happen. Yeah, so all of these I think are very very useful, but it kind of comes down to two main qualities that I think capture what most of you guys are saying. So I think it's one is stability, and the second is throughput. So when you're doing RL, you want your environment and in general your infrastructure that you're doing reinforcement learning on to be reliable and stable. For example, if you use sandboxing to do RL environments, you want your RL environments to have fast cold starts, and you also want it to, be a very stable thing that you can just rely on to be able to do, um, take action. If you want to do inference, you also want your inference to be stable, and in general, you want your training to be stable. And when people talk about checkpointing, I think that also uh, plays into this stability aspect. And then secondly, with throughput, throughput is very important because let's say you're like both this captures both the model throughput and also just your training throughput in general. Later on, I think some people in the chat also talked about quick setup. I think like when you're doing training runs, you really also want to save a lot of time in RL, and you want to have a very good setup, both in terms of like given the same model, you need to train within like a fixed number of steps. If you can do it faster, that's always better. Okay, great. So these two are the end goals we want to have. Obviously, the developer experience is also very important for doing this, but the end result we want to achieve is stability and throughput. So what are some knobs we can tune when designing an RL infrastructure? We can make training better. So these are the training loops. A faster training loop essentially means that you can complete RL in like you complete training your model in a shorter period of time, better rollouts. So if you, let's say, it's important to not waste your rollouts as well. So that's also another thing that is important. You want your rollouts to be fast. That's also important. And then you also can affect your environment. So when you actually have the model like running in a sandbox and so on and so forth, what does that look like? Or in general, what does your training environment look like? So these are the three factors that kind of play into how stable and how much throughput your model ends up having. So I want to cover each one of these and what are some knobs you can tune and what that looks like on Modal next. Okay, so for training, what does it look like to train on a single GPU on Modal? This is a very brief code snippet, but essentially our primitive is using functions. So instead of acquiring a bunch of instances and SSHing onto them to run these training jobs, you can just invoke these jobs as functions. So here we have an image that we created that uses a base image that allows you to do training, install some dependencies, and usually when you're training, you want to grab hold of a full node. If for most things that people are training these days, it really depends. But here we grabbed an H200 and we want all 8 GPUs on it to be able to run some sort of training jobs. So now that we wrote this function, in order to invoke it, all we have to do is to add this local entry point, and we can just call this training function, which is great. Now, what happens if you want to have the configuration that some of you guys talked about? So when you want to have various configurations, you can actually train on multiple GPUs. So here is the same function we had from last time, except you are able to run this function 1,000 times in parallel. So this will then help you acquire 1,000, H200s nodes, each with 8 GPUs, to be able to run whatever is in your function. So that's something that is unique to Modal that you can do as an action. Now, what else can you do when you are running training jobs? You can do horizontal scaling. So how many of you guys have done multi-node training yet on Modal? Maybe some of you, maybe none of you, but this is something that we offer now in beta. So it's now on this webinar. You can, from last time, we talked about just running a training job on a single H200 node of 8 GPUs. What if you need to fit, a bigger model? You want more compute. So here you are able to kick off a multi-node training job by specifying a cluster of size 4, so 4 nodes right next to each other, and they communicate through each other using RDMA. And now we can kick off this training job, and we will just have 4 nodes that are all right next to each other, so the communication is very fast, and be able to specify a job that locks onto more compute. Okay, so why not both? Why not be able to train many multi-node training jobs? So all we have to do is to just call this function multiple times, and yeah. And also, I apologize. I think this is actually vertical, and this is horizontal. I messed those two up, but yeah. Okay, so to recap. To do a training run on Modal, instead of running SSHing into instances, the primitive that we recommend is you deploying these code. And because you can fan out this way, you can do parameter sweeping across all of your different configurations. So you can go from 0 training runs to suddenly many running in parallel, and you can also scale back and forth between various sizes of your training runs. One thing I also want to flag before I move on to the next section is that for multi-node training jobs, this is something that is in beta. So if this is something that you are interested in, please talk to us so we can enable this feature for you. Okay, great. Any questions here? Okay, so someone mentioned, are there tutorials for doing multiple GPU training? Yeah, we have a few tutorials on our document docs website. As for multi-node training, you should just talk to us. And if this is something that's interested in you, we have some guides that are available that I will share today. But like I mentioned before, these tutorials exist, but we do have to enable this feature for you. Yeah. Okay. Any other questions? Okay. Okay. So that's broadly how you do a training run on Modal. So what does the rollout look like? I will talk a little bit less in detail on this, but essentially rollout is 80% of our training time. I depending on what you're doing during training is rollout generation. I believe that rollout's a big bottleneck, and as a company, we spend a lot of time trying to fix this for our users. This is one of the things you can do to fix this. There are more sauce you can do for rollout generation, but for those, I would highly encourage other people to look at our Flash webinars that we have, and as well as other work that Flash is doing. But we are also improving, there are many things you can do to improve your rollouts during training runs, and there are resources that you can see how to do that. And then another thing is slightly related to this, but when you're doing reward computation, there's many things you can do. So you want to have dense rewards. So process reward is something that's important. You also want to have fast reward. So Flash is great for this. And then we'll also walk through an example using LLM-as-a-judge. Yeah. Any questions here? Okay, then I want to talk about environment creation. So that's another thing that we can affect in our RL infrastructure. So the way to do that is with sandboxes. So some tricks you can do, before talking about the tricks, some tricks you can do is you can maintain a warm pool of your sandboxes, and you can also integrate with existing frameworks that help with sandboxing in general, such as Harbor. Modal sandboxing have pretty good cold starts. And we also are able to run sandboxes really at scale. There are many examples of this, but we also just hit 1 billion sandboxes ran very recently, which is cool. So why do we need a warm pool? A warm pool is important because when you are doing reinforcement learning, usually you want to, like, let's say you are like improving this model, and when you're improving it, you want to then evaluate it by running it on a bunch of sandboxes, or you want to use the sandboxes as RL environments. Usually you have a good idea of like how many sandboxes you need. So instead of spawning them every single time you need to create them, you can keep it in a pool. So this will look a little bit like this. So here we have an example script that creates a warm pool of sandboxes. So to walk through what this looks like, you create an app with your sandbox pool. You specify how long your sandbox should live for, how many sandboxes you want to create a warm pool for, and then you have a function to create a sandbox. That is the sandbox create primitive that I talked about. And then you just make sure that your sandbox is available. And this refresh pool function will just run every, let's say, any time interval you want, like 5 minutes. And as long as you have like this fixed number of sandboxes, it will be fine. And then if there's any missing sandbox, it will create additional sandboxes for you. Yeah, so let's actually run this and see what this is doing. So I'm going to run this locally, and what the modal function will look like is it will look like this. You'll have a function that I just deployed. It has refresh pool, and it has this test function that I wrote to see if this sandboxes are available. This is a cron job, so when you run it, it will then try to maintain a warm pool of this many sandbox. This just gets automatically triggered, but I like manually triggered it just now. So you can see here it's running. And if we go back here, you can see that we have a bunch of live sandboxes that we are trying to create. So now you have sandboxes that you can, and they come up very quickly. So now you have sandboxes that you can use for your environments, and these sandboxes are stable as well, which goes into what we talk about as what's important. Yeah, so these are the 3 things that people can do to improve their infrastructure, and how you can do that with us. Yep. Any questions here? Okay, so now we're going to walk over some common design patterns of people using us. So first thing people do is you can do async RL on Modal. We can walk through a code example of this later if this is something that's interesting to people. But yeah, you can run async RL using Slime on Modal. We also have example on Miles, so on and so forth. Yeah, so here's an example. I can do a very brief code walkthrough. So what does it look like to do something such as Slime on Modal? So here we have the main entry point for running Slime on Modal. So essentially what this encapsulates is that you have an image that is based off of the Slime image. Then afterwards you have a bunch of volumes. So here's a volume on some data that we want to use for this example. We have some the Hugging Face cache, and then we also have a volume for checkpointing. In this example, we use Slime with Ray. So these are some Ray configurations. And then all we have to do when we kick off this job is that we just run the function download model, which downloads a model from Hugging Face to this volume. We prepare a data set, which also prepares the data set to the data volume. We then can just run train, either with multi-node or a single node. And this is a variant of the function that I walked through before. So in this example, we first get the exact configuration we want to train on. And because it's a multi-node job, the way you access each node individually is you can get cluster info. And then after you get the cluster info, you are able to then start Ray with, this is the rank 0 node address, and then some other addresses, and you just run training. So you see that when we're doing here, we can get various configurations. So you're able to specify different configurations and train on us. We also have a bunch of other examples on using us. And all you need to do once you write this code is you just have to run this to be able to invoke this training. Someone asks, what does Hugging Face cache do? Yeah, so Hugging Face cache, let me just go back to sharing the screen. The Hugging Face cache is just a general pattern that we like to do at Modal. So when you have things, if you just look at where this is being referenced, if you have, download your model, if you have a different volume for downloading your model for every single function that you have, you could have waste, because let's say you have function A that needs to download Quen 4b, and you have another function that also needs to train Quen 4b. The base model for these are the same, so you don't really want to download them to different volumes. So what I like to do is I just like to have a single Hugging Face cache that stores all of these base models that I have, to be able to work easier, and just every single time, I don't even need to download the model sometimes. It just already exists. How is this different from a fine tune on an existing model? What this is doing is that this is using Slime to fine tune an existing model. If that's your question. Someone asked, what's the async RL aspect here? We have various configurations. So in Slime, to do async RL, you just have to set some configurations. So we set that here in this example. Any other questions? Okay. Yeah, I think the last thing I want to touch on is that we are a platform instead of a point-based solution. So we have all these building blocks that you can use to do RL and fit into your various workflows. Now I want to walk over some use cases I have. So here's one, which is people were talking about how we can maybe do parameter sweep, or just in general, like what scaling on Modal looks like. So here is like a code demo of what that looks like. So we trained a model to write haikus with various configurations. So various like configurations, and just like did a modal map over all of these configurations. And here are some of the results that we got as a result. So this is the base model. Haikus are very interesting because they have to follow a 5-7-5 format, like 5 syllables, 7 syllable, and then 5 syllables. But at the same time, there is something qualitative about it, which is what makes a haiku actually good. So here, the base model, as you can see, it didn't get the syllable count right. And then we trained it with LLM-as-a-judge. Here's training it without using LLM-as-a-judge. It's just training it on kind of like the regular like syllable count grading. And then we had various judge configurations and trained the results. We also did checkpointing and captured all the checkpoints, so we can see based off of for each judge configuration or training configuration what the result looked like over time. So here's like an example, and then we can have another one about training, and then here is an example of what the result looks like. So a walkthrough of this code looks very similar to the slime example that I just shared earlier. I think some changes is that we have now this tab of LM judges. So we talked a little bit about Flash before. I think something great is that you can deploy these judges also in parallel. So you can specify a base judge configuration, and then when you deploy, all you have to do is you specify the different types of judges you want, and then you enumerate all of them, and you just like deploy all of them together when you kick off your training run. Okay, someone asked, is this open sourced? Yes, we will share all the links for this at the end of the presentation. Someone says, why use Slime versus Nemo versus Vero? I think there are reasons for all of them, but luckily we can support all of them running on Modal. So, if you have questions on using them, feel free to let us know. Okay, so another example, any other questions here? But essentially, this is an example of being able to do LLM-as-a-judge on Modal, and also be able to kick off all these different judge configurations and training in parallel. Something else I think this is also useful to showcase is that because once, even as you're training, you can see the checkpoint and then host them. This is also something you can do while you're training to kind of sanity check your outputs, especially when your results are kind of harder to grade instead of it succeeded or if it failed. Okay, so the next thing I want to cover is code golf. So code golf is this pretty cool thing that exists outside of Modal. Essentially, you have all of these puzzles, and you want to be able to write code that solves these questions. And usually, this can be this is just graded on how good your solution is in terms of correctness, and then if it's easy to read. But for code golf, what people are graded on is that they're graded on how long their responses are. So that's pretty cool, and that's definitely something we can train an LLM to write. So in this case, what we ended up doing is we trained we trained a model using Slime and Harbor to be able to write code and solve these code golf questions. And because we use Harbor is a framework that allows you to do training with RL environments that are sandboxes. So here, some interesting code to walk through is that when we are training this, every single time we do sandbox, every single time we kind of like grade whether this code, our actual code is good or not. We need to actually be able to run it, because a code could be really, really short, but if it doesn't actually execute and pass the test cases in Code Golf, it wouldn't actually work. So here we are defining a custom reward model function in a file here. And whenever we want to score what our results are, you can see we spawn a sandbox, execute it, parse the result, and then return the score sample function. So that's something you can also do with Modal. That's pretty cool as well. Any questions here? Are rollouts compatible for multi-node turn or a single turn inference? Yeah. So, I think that's a pretty specific question to inference. So we'll answer that asynchronously. Yep. Okay, great. The last use case I want to walk over is using EXA using us to create these search evals for coding agents. So this was like a few days ago, but essentially they wrote a very cool blog on something they did, which is building a search eval for coding agents. And something that is cool about this is that they're actually using modal sandboxes to verify how correct their actual they're performing in this suite. So this is also something pretty cool that people use this to do, and highly encourage everyone to check them out. I think this project that they worked on is just like pretty interesting in general as well. Okay, so that's kind of all I have in terms of content for using us with training. As always, you can sign up for an account on modal.com. Some examples you can clone linked here, but we'll also link the rest of them that I showed earlier. And yeah, thank you for everyone for listening. Does anyone have questions? People were asking the link to that blog. I linked it here at the bottom. That's the link. Okay. Any other questions? Okay. If not, thank you everyone for listening. This video will be recorded and shared later. And yeah, thank you everyone.